Hello, my Algebra 2 gems. Today we're going to get started with our Week 2 Video 1 notes. We're going to be talking about some angles and the unit circle today. So just as a reminder, if you go on to Edmodo and you go into the Week 2 Video 1 homework, you will see a PDF that has both the notes and has the homework attached to it as a PDF as well. So as I'm going through these notes, if you would like to follow along, if you have a printer and you can print out these notes, that would be really helpful. If you don't and you just want to take these notes by hand as I kind of go through, you're more than welcome to do so. So whatever kind of works best for you. So the first thing we're going to talk about today are angles that are in something called standard form. So essentially what we think about is an X and a Y axis. If we're on the X axis over here on the right, this is 0 degrees. If I go to where the Y axis would be straight up and down, that's in 90 degrees. So every one of these sections or quadrants is 90 degrees. So from 0 to the first one, that's 90. From 90 to the next one, this is another 90 degrees. So in total, if I started at 0, I'd go all the way around, that's 180. I add another 90 to it, that gets me to 270, and then I add another 90 to it, that gets me back to either 360 or, in this case, 0. Okay, so it makes a circle, which is why we're talking about a unit circle, and it goes all the way around to give me 360 degrees. Now, an angle on the coordinate plane is in standard form when the vertex is on the origin. So vertex means the point where my two rays come together. The origin 0, 0 in the center. And one ray lies on the positive x-axis. So here's the ray that's on the positive x-axis. So as long as an angle starts here, that means it's in standard form. The ray on the x-axis is called the initial side. Okay, so this angle right here in blue, this is my initial side. The other ray that shows you where your angle is finishing, so this orange one here, is called the terminal side. Okay, so initial is where you start, terminal is where you end up. Okay, so if I go from this starting place, which is on the x-axis, if I go counterclockwise, so that means to the left, these rotations are going to be positive angle measures. So when I move to the left, that's positive. So if I went from this first ray, the initial side, and let's say my terminal was at the 90, this, if I go to the left, that would have been 90 degrees. If I go again, that would be 180 degrees, okay? So if I'm going to the left counterclockwise, I'm going to have a positive angle measure. If I go the other way, if I go to the right, okay, make a clockwise rotation, right? Going around and around to the right, clockwise, are going to give me negative angle measures. So I can have positive angles or I can have negative angles on a unit circle. If I go around one full time, right, that's 90 plus 90 plus 90 plus 90, gives me a circle. That's going to be 360 degrees. So now what we're going to do is we're going to have a little bit of practice drawing some angles. So we're going to sketch an angle with the given measure in standard position. So if it's in standard position, the initial side needs to be on the x-axis. So I'm always going to start by drawing my initial side on the x-axis. Now my first one is 75 degrees. So I know it's a positive, which means I'm going to be going counterclockwise and moving to the left. I know if I go to the y-axis, this is 90 degrees. Well, 75 is less than 90, but it's a little further than halfway, which would be 45. So I'm going to draw an angle that's closer to the 90, something that looks like this. And I started from the initial side. I went to this arrow, to this terminal side. That's what your 75 degrees would look like. And it's not perfect. We're just sketching something that would be somewhat close. Okay. The next one, I can make these a little bit bigger here. Next one is a negative 160. Okay, so if it is a negative, that means I'm not going clockwise, or excuse me, I'm gonna go clockwise because I wanna have a negative. Counterclockwise to the left would be a positive. So I'm gonna start on my initial side right here. Okay, here's my initial side. Now, you gotta kind of think of it like if you were going backwards. So if I went from here to this first y-axis, this would be negative 90 degrees. If I went another section or another quadrant, I'd be at negative 180 degrees. Well, I'm at negative 160. So that means I'm not quite to this negative 180 over here, but I'm really close to it. I'm only 20 degrees away. So I'd be something like that. And I go from the initial side, and I always draw which way I'm going because I know if it's going to be a positive or a negative. Since I'm going in a clockwise motion here, this means this is a negative 160 degrees. Okay, I always have to draw my arrow where I'm going because that tells me if it's positive or negative. All right, next one, 430 degrees. Now, I know that 430 degrees is greater than a full revolution. One full revolution would give me 360 degrees, but I'm at 430 degrees, so I want to know how much more I'm going than the 360. So in order to figure that out, I can take the 430 and I can subtract 360 from it. Because if I do that, that means I go a whole circle, 360, plus I go another 70 degrees. So here's what that looks like. I start on my initial side here. Because it is positive, I'm going to be going in a counterclockwise rotation. So I'm moving to the left. So if I start here, I go all the way around. Whew, that's 360. Then I need to add another 70 degrees to it to get me to 430. So 70 is between, right, the 0 and 90, but it's close to the 90, so it's maybe right about there. So I'm going to draw my terminal side, and I'm going to continue my arrow all the way over there. So it makes a full revolution, and then it goes another 70 degrees. That is 430 degrees right there. So now you have drawn some angles. Okay, now, you are going to see, as we start talking about a unit circle, you're going to be seeing either something called radians or something called degrees. And that is when we look at our, if you look at your calculator, we always do things in degrees. And you know, sometimes you guys are asking me like, oh, if I look at my phone, sometimes it says RAD and we're getting different numbers. RAD is a radian, so it has to do with pi. If we're talking about degree measures, we're talking about out of 360. We're talking about degrees. So it's just another way for me to write degrees using a different kind of label. So a radian is a unit of angle measure based on arc length. 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. Recall that the circumference of a circle is 2 pi r. Therefore, if I were to go a full revolution, a full circle, 360 degrees is 2 pi radians. 180 degrees is half of that. So 180 degrees is just pi radians. So what we're going to practice doing is converting from degrees to radians and from radians to degrees. Now, in order to convert from degrees to radians, I'm going to take whatever the degree is, I'm going to multiply it times pi radians over 180. If I'm going from radians to degrees, I'm going to do just the opposite. I'm going to multiply the radians by 180 over pi radians because I want the degrees to cancel and I want the radians to cancel over here. And so I'll show you what I mean. First one we're going to do, we're going to practice converting each measure into radians. So I've got a degree here, 30. I'm going to multiply it times pi radians over 180. Now, this is a fraction, so this 30 doesn't have a number under it. If you would like, you can put a 1, and then we just multiply straight across. So I get 30 pi over 180. Well, I can reduce 30 over 180, right? I can divide 30 by 30, I get a 1. I can divide 180 by 30, I get a 6. So I end up with just pi over 6. Number 5. So I've got 150 degrees. I'm going to convert it from degrees to radians. So I've got 150 times pi over 180. And do the same thing. Multiply straight across. I get 150 pi over 180. I can reduce this fraction. Let's see, 180. I can divide them both by 30, so I get 5 pi over 6. So I've converted from degrees to radians. So 150 degrees is the same thing as 5 pi over 6. All right, last one. Negative 220 degrees. Same thing. I'm going to multiply this times pi over 180. So I get negative 220 pi over 180. And I can reduce that. I can divide them both by 20. So I get negative 11 pi over 9. Negative would just mean that you're going a different way, right? A negative means you're going to be moving clockwise. These positives means you're going to be moving counterclockwise. Okay, so we've converted from degrees to radians. Now we're going to do just the opposite. We're going to convert from radians to degrees. Okay, make sure you can see it. Zoom in just a little bit more. All right. So now, when we are going to convert into degrees, we're going to do just the opposite. Instead of multiplying by pi over 180, I'm going to multiply by 180 over pi. And the reason I'm going to do that is because when I multiply here, you're going to notice you've got pi divided by pi. These pi's cancel out. And then it's just some simple algebra. So if I do 4 times 180, I get 720. And then if I divide that by 3, I get 240 degrees. So 4 pi over 3 is the same as 240 degrees. I'm going to do the same for number 8. 5 pi over 36, and this is a negative. I'm going to multiply times 180 over pi. My pi radians are going to cancel. Negative 5 times 180 is negative 900. And then I've got a 36 at the bottom. And if I divide those two, I get negative 25 degrees. Simple stuff. Same for our last problem, number 9. I've got 7 pi over 4. I'm going to multiply by 180 over pi. My pi radians cancel. 7 times 180 gives me 1,1260 all over 4. I divide those, I get 315 degrees. So you should be able to go back and forth between radians and degrees. All right, now next section is we're going to be talking about something called coterminal angles. So remember, terminal means where the angle is going to end on that unit circle. Coterminal means that there's going to be 2 different ones that are going to end in the same place. So angles in standard position with the same terminal side are called coterminal angles. So for each of our examples here, we're going to give 2 coterminal angles for each of the angles. One's going to be positive and one is going to be negative. So essentially all we're going to do is we're going to take our degrees. We're either going to add 360 to it, so we're going to add a full revolution, or we're going to subtract 360. We're going to take away a full revolution. And that will get me to end at the same point, even though I might have that I started at. So for example, 65 degrees. A coterminal angle with 65 degrees means, if I were to draw 65, it would start here, and it would end somewhere about here, right? This is about 65 degrees, right? From here to here. Now, if I add 65 plus another 360, that means I do a full revolution, and then I come back around to that 65. So I'm just adding another revolution to it. So when I add those two together, I get 425. And that is coterminal with 65. That's one of my answers. Okay, that's if I go to the left, positive. If I want to make it a negative, I'm just going to rotate around to the right. So I'm going to take the 65 and I'm going to subtract 360 from it. And when I do that, I get negative 295. So 65, 425 degrees, and negative 295 degrees all have the same terminal angle. So they all end in the same position, which is really cool, right? Because you're just going around and around and around and around in a circle. So you could go one time around, you could go two times around, right? There's an infinite number of possibilities of numbers that have the same terminal side as this one, because I can just continue to add 360 to it, right? Okay. Let's do the same over here for number 11. So now I have 540. That's already greater than my 360. So I want to figure out what number would be less than that one, less than a 360. So I'm going to take my 540. I'm going to subtract 360 from it. I get 180 degrees. So that is a positive angle that still ends in the same place. 540 and 180 end in the same place. To find myself a negative, I'm going to take that 180 and I'm going to subtract 360 from it. Now, the reason I'm taking that 180 and subtracting 360 is because I want a negative terminal number. If I do 540 minus 360, I'm just getting myself to a positive number. You also could have just added 540 plus 360 and got an even bigger number. But I subtracted because I was trying to find a number that was smaller so that when I got to the next step of making it negative, I had a number that was small enough to make this negative when I subtracted. So when you subtract 180 minus 360, guess what? You get negative 180 degrees. So all three of these angles are coterminal. They have a terminal sign that ends at the same number or same angle. Okay, now number 12 and 13 are a little bit different because they are given to me in radians, but that's not a problem. I can still do this the same way, except instead of me adding 360 and subtracting 360, I'm going to be adding it in radians. 360 is the same as 2 pi. So I'm going to be adding 2 pi and subtracting 2 pi. So I've got 13 pi over 18, and I'm going to add 2 pi to it. Now, I cannot just add these two together because they have different denominators. So I have to have them having a common denominator in order to add them together. Well, I can multiply 1 times 18, and that will give me the same denominator. So I'm going to multiply times 18 on the top and on the bottom. So I end up really with 13 pi over 18 plus, so if I multiply 18 times 2, I get 36 pi over 18. All right, so if I add those two together, my coterminal side is going to be 49 pi over 18. There's my positive. To find the negative, I'm going to do 13 pi over 18, and I'm going to subtract 2 pi, but I'm not going to subtract it as 2 pi. I'm going to subtract 36 pi over 18, right? Because I want them to have the same denominator. So when I subtract those, I end up getting negative 23 pi over 18, which looks like a crazy number, but we could always change it into a degree if we really wanted to. Okay, now let's do the same for number 13. So I've got 14 pi over 9, and I'm going to add 2 pi to it. Well, again, just like the last problem, these have different denominators, so I'm going to multiply this by 9 on the top and 9 on the bottom so I can have the same denominator. So I really have 14 pi over 9 plus 18 pi over 9. All right, so when I add those numbers together, I'll come up here, I get 32 pi over 9 as my positive. And then to find my negative, I'm going to do 14 pi over 9 minus 18 pi over 9. And I end up getting for my negative a negative 4 pi over 9. Okay, and there we found our coterminal angles. All right, last section, then we're going to do a couple examples. Last section is reference angles. So for an angle, theta, that's given in standard form, the reference angle is the positive acute angle formed by the terminal side on the x-axis. So essentially, here's what that means. If I give you this angle right here, and let's say I told you that this angle right here is 130 degrees. The reference angle is whatever is left over to get me to the x-axis. So if this whole thing, like I said, was 130 degrees, this down here, this x-axis is 180 degrees. So to get myself from 130 to 180, I have to add another 50 degrees. So my reference angle would have been 50 degrees. It's what's left over to get me to the x-axis. So we're going to sketch these angles to start, and then we're going to figure out what are, or not just the x-axis, it can be the x or the y-axis. I'm going to figure out what is like the leftover piece for each one of these. Okay. So I've got, let me zoom in here, I've got 225 degrees. So I start on the x-axis. This first one, this is 90, and it's a positive, so I'm going to go to the left. So this is 90, this is 180, this is 270. Okay, so 225 is somewhere past 180, but not quite at 270, so it's something like this. So I start here, I go all the way over at 225 degrees. So the reference angle is this space that's left over here. So I'm going to end up doing, to get from here to here, this would be my reference angle that's left over. Okay, because this is me, I'm already past the 180, I have to get to the next axis, which is the y-axis, so this would be my reference angle. This axis right here is 270. So I'm going to take 270 and I'm going to subtract 225. And when I do that, I end up getting 45 degrees. So this space that's left over is 45 degrees. And that's it. I'm done. So let's try the next one. Next one is a negative 310 degrees. So because it's negative, I'm going to be going clockwise. Now, if I'm thinking about this going the opposite way, so I start here, right? Let's say that this would be my negative 90, negative 180, negative 270. This would be 360, but I'm definitely not at 360. I'm past 270. So I would look something like this. So I'm going the opposite way, right? I'm going this way, clockwise. That's a negative 310 degrees. So the closest one, I'm trying to figure out this angle that's left over, right over here, right? So I can do 360 minus 310, and that'll tell me what's left over. So here's 360, right? This would have been 310. So I'm doing 360 minus 310. And if I do that, I end up getting 50 degrees. That's what's left over. Another way you can think about it is if you say this is 270 and I have to get from 270 to 310, that means to get from 270 to 310, I have to add another 40 degrees. So this would be a 40 degrees. 40 plus what gets me to a 90 degrees, and 40 plus 50 gets me to 90. So it's another way you can think about getting this leftover piece if you don't like doing the whole big numbers here. All right, we're actually going to skip this one. I don't want to do radians right now. Okay, so we're going to do some examples here where we find the measure of angles. So we're going to find the measure of each angle as a positive angle measure, a negative angle measure, and an angle measure that is greater than 360 degrees. So we're finding terminal angles for each one of these. Okay. There are 4 different quadrants when we look at a graph here. I know my first quadrant's up over here. It's all the positives. My second quadrant's over here. Third one's at the bottom left. The fourth one's the bottom right. Okay. Now, in this problem, I see that I am starting over here. Here's my initial side. My terminal side is down here in the 4th quadrant, and I am going clockwise. Because I'm going clockwise, that means this 60 degrees is really a negative 60 degrees. Okay, so it already is a negative angle measure. If I wanted to make that a positive, that means I would have to start over here at my initial side, and I'd have to go all the way around over here. So from 360, I have to go all the way over to here. So in order to find that, I could take 360, which would be the whole circle, and subtract the 60 from it. If I do that, I get 300 degrees. And there it is as a positive angle value. So negative 60 and positive 300 degrees are coterminal angles. Now, if I want to find an angle measure that is greater than 360 degrees, all I have to do is take my positive angle and I have to add 360 degrees to it, because that means make a full revolution and then come do another part of this revolution to get you back to this terminal side. So I'm going to do 360 plus my positive is 300, and I get 660 degrees. So all 3 of these, negative 60, 300, and 660, those are all coterminal angles. Oh, I guess I should move it up. My bad. Okay. Coterminal. Okay, that's essentially all I'm asking you to do for these problems. So let's look at letter B. I see that I'm starting here on the x-axis. This is standard form. My terminal side is over here. I see that the reference angle is 60. What's left over is 60. Okay, that means 60 plus what gets me to this 90 right here? That would be a 30 degrees on the inside. So I've got 90 plus 30. That means my total is 120 degrees, and I'm going to the left, which makes it a positive. So there it already is for me as a positive value. Now, to find it as a negative value, I'd have to go the other way. I'd have to go to the left, and then I'd have to add this reference angle in. So I'd have to go negative 90, negative 180, and then negative 180 minus another 60. That would give me a negative 240 degrees. So that's going the opposite way. Last one, to find it as a angle measure that's greater than 360, I'm just going to take 360, and I'm going to add my positive angle value to it. So that's 120. So if I add those together, I get 480 degrees. I've got all of my coterminal angles. All right, last one. I see that I've got, here's my initial side. My terminal side is over here. Okay, now I see that I'm already going to the left, which makes this a positive. So I'm going to the left 90, 180, 270, and then I have to figure out what this little piece is. Well, I know that this reference angle is 45. What's left over, 45 plus what gets me to 90, this is another 45. So I'm going to add 90 plus 90 plus 90, so that's 270 plus 45. And I get 315 degrees for my positive value. For my negative value, it's super simple. I start at the initial side, I go to the terminal side, I go clockwise. Well, it's already stopped right there. It tells me what it is. It's a negative 45 degrees. So these are coterminal. Last one, to find one that is greater than 360, I take 360 and I add my positive value to it, which is 315. When I add this together, I get my positive value as 675 degrees, my coterminal angles. All right, now for our last section. Our last section is very similar to what we just did, except for this time, we're going to use reference angles in order to find the standard position for different angles in different quadrants. So for my first one, I'm telling you that the reference angle is 10 degrees. So reference angle means what's left over. So I'm going to draw myself a picture for each one of these. And I'm going to make sure that I label my different quadrants. So I'm going to label quadrant 1, 2, 3, and 4. Okay. Now this one says a 10-degree reference angle in quadrant 2. So that would mean if I started here on the initial side, my terminal side would end in quadrant 2 with only 10 degrees left over. So this little piece is 10 degrees. Okay, now I'm going, this is 90, 180, 270. Okay, so if I'm going to the left and I'm almost at 180, but I'm not quite there, I have 10 degrees left over, well, that's super simple. All I have to do is say, well, it was 180, but there's 10 degrees left over, so I'm going to subtract that from 180. That means my angle is a positive 170 degrees. And you're done. So you don't have to do anything else. So the reference angle, what's left over, is 10 degrees. The other part is what do you have to add to it to get yourself to the next quadrant. All right, letter B, 35 degrees in quadrant 4. So I'm going to do the same thing I just did. I'm going to label my quadrants. All right. So if we're in quadrant 4, that means we're down here. The reference angle that's left over is 35 degrees. Okay, so this little reference angle in here is 35 degrees. That means I started on the x-axis, I went 90, 180, 270, and then whatever's left over here, that gets me to 360. So what you can do is say the whole circle would have been 360, but I'm taking away what's left over, the reference angle. So I'm going to do 360 minus 35. I end up getting 325 degrees. That's my final angle. So my initial side and my terminal side are over here. You also can think about it as if this reference angle is 35, you say 35 plus what gets me to a 90-degree angle? Well, that would be 55. So you can say 90 plus 90 plus 90 plus 55, and that will also get you to 325. So you're kind of free to do it however you want. So if you also want to do 90 plus 90 plus 90 plus 55. Right, and that still gets you the same answer. So there's multiple ways to get to the same answer here. All right, that's my final one. Last question. 34 degrees in quadrant 3. One more time, I'm going to do the same thing. Label my sides X and Y, and then I'm going to label my quadrants. Okay, so now we're in quadrant 3. Okay, 1, 2, 3. So if I'm looking, what's left over is going to be 34 degrees. Now, if I start over here on the terminal side and I go all the way over and around, that means I'm including that reference angle with mine. So I'm going to end up doing 180 plus this reference angle of 34, and that's going to give me my final answer. So I'm going to do 180 plus 34, and I end up getting 214 degrees. And I'm finished. So now you are ready to complete your week 2 video 1 homework. Again, if you go to Edmodo and you go into the week 2 video 1 notes section, you will also see a link there for your homework. Your homework is just like the last ones that we've done before, where it's a Google form that you're going to submit. So you do not need to send me any pictures or anything. You just need to submit your work. And keep your work as well, because we will have an opportunity to check our answers and ask some questions. Okay, so we're finished with our first video of the week, and you guys can go ahead and get started on your homework. Have a great day.